Hello, and welcome to Teacher Gimble's channel. Today we'll be going over Illustrative Math Unit 1, Lesson 20. If you like this video, please make sure to like and subscribe by pressing the button down there. And if you want personalized videos, in my bio you can find a link to my Patreon. And if you subscribe there, I can go ahead and I will make you personalized videos on any math topic that you need, whether it be illustrative math or something different. Let's get started. Problem 1. Priya, I bet if alternate interior angles are congruent, then the lines will have to be parallel. Han, really? We know if the lines are parallel, then the alternate interior angles are congruent, but I don't know if that works both ways. Priya, well, I think so. If angle ABC and angle BJC are both 40 degrees, so we're going to look at the figure. ABC is 40 degrees. BCJ is 40 degrees. If I draw a line perpendicular to line AI, right here, perpendicular to AI, through point B, I get this triangle. Okay, so the triangle Priya is talking about right now is this triangle right here. Angle CBX would have to be 50 degrees. It's because we're perpendicular, so if it's 90 on this side, it's 90 on that side, because 40 plus 50 is 90. And because all angles of a triangle sum to a right angle, CXB is 90 degrees, so it's also a right angle. Oh, then line AI and GJ are both perpendicular to the same line. So that's how we constructed parallel lines, by making them both perpendicular to the same line. So lines AI and GJ must be parallel. Label the diagram based on Priya and Han's conversation. I believe we just did that. So notice we were doing it as we read the conversation, because it's always good to label as you read. And we went ahead and we did that. Is there something special about 40 degrees? Will any two lines cut by a transversal with congruent alternate interior angles be parallel? Well, let's think. Let's pretend it's not 40 degrees. Let's say it's 10 degrees. This would still be 90 degrees. This whole thing would still be 90 degrees, which would make this 90 degrees. Oh, not 90, it would be 80 degrees, because they have to add up to 90. We then know, well, we have this is 10, which would this be 10? 10 plus 80 is 90, which would mean this is 90 right here too. So yes, it works with that. And what we notice is these two are always going to have to add up to 90. And these two, because this and this will be the same, will always add up to 90. Therefore, this angle will always be 90, because these two angles will always be 90. So this angle and this angle will add up to 90 degrees, because we'll always have this as a perpendicular. This and this angle are the same, so these two add up to 90, but because these are the same, these two also add up to 90. And if these are 90, this has to be 90. So it doesn't matter if it's 40 or 50 or 10 or whatever it is. If the alternate interior angles are congruent, it means that the lines are parallel. Now, I would take a second, if you're going over this yourself, I would reread the scenario and see if you can label it on your own, because these types of questions require quite a bit of thinking, and they're a little bit difficult to do. So work on them through yourself is the best way to kind of figure out how to do these independently. Problem 2. Prove lines AI and GJ are parallel. Well, to prove that they're parallel, we need to prove that these two guys are perpendicular, but we don't know that he's perpendicular yet. But we do know that this is A, and we know that vertical angles are congruent, so this is also A. And now we have our alternate interior angles are congruent, and we just learned in the last example that if the alternate interior angles are congruent, then the lines in that transversal are parallel. So we're done. But what we could also do is we can say, okay, this is going to be B, and we're not actually going to call him B. We're going to call him something else. We know if this is 90, this has to be 90. So instead of calling him B, we're going to say we know this guy is going to be 90 minus A. So if this question mark, we want to know what he is. Question mark plus A plus 90 minus A is always going to equal 180, because we have this angle, and this angle. Now these two A's are going to cross themselves out, which tells us question mark plus A is equal to 180. We subtract 90 from both sides. which means question mark will be 90 degrees, which is what we are trying to prove. So yes, the lines are parallel, both because alternate interior angles are congruent, but we can prove it by looking at this triangle here and proving this guy's a 90-degree angle, which tells us this is a 90-degree angle, and that's how we've constructed parallel lines in the past. Let's go on to problem 3. What is the measure of angle ABE? These guys are vertical angles, 50 degrees. We're done. I love vertical angles. Problem 4. Lines AB and BC are perpendicular. So AB and BC, that means it's a right angle. The dashed ray bisects angles ABD and CBD. Explain, so ABD is bisected by the dashed lines, and CBD is also bisected by the dashed lines. Explain why the measure of angle EBF is 45 degrees. Ooh, this is a fun question. We've gotten to the fun part of geometry. So EBF, why is that 45 degrees? Well, I know that the measure of angle ABD, so ABD is this guy right here. We're going to call him, well, we're going to add him, plus the measure of angle, this guy right here, CBD, has to equal 180 degrees because it's a right angle. And I also know that this guy over here is 1/2 of ABD plus this guy over here, which is 1/2 of CBD, is equal to the angle that we're thinking about, which is EBF. This over here is going to be 1/2. I can just undistribute. I can factor out, that's the word. I said undistribute. That means factor out CBD is equal to EBF. Now notice ABD plus CBD is 180. So I can just replace ABD plus CBD right there. And I can go ahead and ABD plus CBD, I put 180. It should be 90 degrees. That was my bad. I'm sorry. Sometimes when I do math as I speak, but it's a right angle, not a line, which means this is 90 degrees right here. And we get 45 degrees is equal to EBF. So we proved knowing none of the actual measures of the triangle. So the two angles, this one and this one, add to 90 degrees. The dashed lines bisect both of those angles. So when we're looking at this angle plus this angle, this one and this one, it's half of both of those angles. And we're calling them EBF. When we pull out the 1/2, we factor them out. We have this sum, which we already know is equal to 90. And then when we just say, okay, it's equal to 90, we can prove that EBF is equal to 45 degrees. And that is the proof for that one. If you have questions, please put them in the comments below. Moving into proofs is a different way of thinking, and it takes a lot. So I would recommend watching this video several times if you need help thinking kind of how these proofs work. Problem 5. Identify a figure that is not the image of quadrilateral ABCD after the sequence of transformations. Explain how you know. ABCD. Well, a sequence of transformations is going to give us a congruent figure. And a figure that I see is not congruent is this big figure right here. He is much larger than ABCD and will not have a sequence of transformations that brings him to over him. So that's my answer. All right, problem 6. Quadrilateral ABCD is congruent to quadrilateral A prime, B prime, C prime, D prime. Describe a sequence of rigid motions that takes A to A prime, B to B prime, C to C prime, and D to D prime. So I'm going to take C, I'm going to drag him over to C prime, which is going to bring my whole shape down, kind of just how it is. That's a terrible shape, but you get what I'm saying. D, B, A. After the dragging was a translation, I am then going to rotate some amount clockwise. I would estimate that to be, let's see, this line right here is going to go to this line over there. So it looks at about a 60-degree rotation. I would rotate 60 degrees clockwise around point C prime, and then it would line up those two images. And we're done. There's a lot more examples on those on earlier videos if you need to go over it. Triangle ABC is congruent to triangle A prime, B prime, C prime. Describe a sequence of rigid motion that takes A to A prime, B to B prime, and C to C prime. Well, we can take A to A prime by dragging over, which brings our whole shape over there. We always bring our points with us, and then we're going to rotate. This guy is going to rotate onto that guy. That looks like a 60-degree rotation. We're rotating 60 degrees counterclockwise around point A prime, and it's going to drag this triangle smack on top of that triangle. And we're done. All right, next question. Problem 8. Identify any angles of rotation that create symmetry. Well, we're going to take this pedal, and we're going to want him to go to this pedal. In this angle, we have 1, 2, 3, 4, 5, 6 little angles at 180 degrees, which tells me each of them are 30. That line kind of 1, 2, 3, 4 goes over 4. That's a 120-degree rotation. We could also rotate it one more, which would be 120 plus another 120, which is a 240-degree rotation. And the third 120 would go 360, which we don't actually count because that just brings the pedal back to itself. So the angles of rotation that create symmetry are 120 and 240. Problem number 9. And we're going to zoom out for this question. Select all the angles of rotation that produce symmetry for this. So this guy, to go from here to there, looks like it's 60 degrees. 1, 2, 3, 4, 5, 6, 7, 8. 180 divided by, there's 8 of those. 1, 2, 3, 4, 5. So each 90-degree segment is split into 4 parts. So there is 8, so it's 180 divided by 8, which we're going to go ahead and we're going to figure out by our handy-dandy calculator to determine the exact angle of rotational symmetry here. So 180 divided by 8 is 22.5 degrees. So it takes 22.5 degrees to rotate one pedal to the next pedal. But it is 2 of those angles, so it's actually going to be 2 22.5s, which is 45 degrees to rotate one pedal to the next. So one pedal going to the next one is going to be 45 degrees. So 45 degrees will work. 90 degrees will work. 90 plus 45 is 135 degrees will work. 135 plus 45 means 180 degrees will work. 180 plus 145 means 215 degrees will work. And we notice we've exhausted all of the answers. And so we're done. But you just keep adding 45 and you'll get every degree of rotational symmetry for this question. All right, let's go on to the next one. 3 line segments form the letter N. Rotate the letter N clockwise around the midpoint of segment BC. So we're going to rotate clockwise by 180 degrees. Describe the results. Well, let's think of this segment. Rotate at 180 degrees. He's going to line up over there. This segment is going to go over here. And I believe the N is going to line up exactly on top of itself. I would pull out a piece of tracing paper to verify that. But as you can see, C is going to go to C, A is going to get dragged to D, and this point is going to stay right in the middle. All right, if you have any questions, make sure to put them in the comment below. If you like this video, make sure to like and subscribe, and I will see you in the next one.